For section 5.2, we are talking about the properties of quadratic functions in standard form. So last section we looked at vertex form. Now we're going to move into standard form. So the first vocab word we have is axis of symmetry, and that is the line that goes through the vertex of the parabola and it divides the parabola into two congruent halves. So in other words, if you took the parabola and folded it in half and opened it back up, the line that would be formed on your paper would be the axis of symmetry. Now, in vertex form, remember we talked about this formula last week. The axis of symmetry is the value of h. It's the line, that's where it's telling you on the x-axis where that line of symmetry is. So when you have something in vertex form, it's very simple to find the axis of symmetry. When it's in standard form, we have a little bit more work to do. So over here on the right-hand side, we have a picture. The red is the parabola, the graph. The blue dot is the vertex. Remember, the vertex is the highest or the lowest point, minimum or maximum, depending on how that parabola opens. And then the dotted line is our axis of symmetry. So for example 1, we need to identify the axis of symmetry of the graph and of this function. So the first one is 2 times the quantity of x plus 2 squared minus 3. And remember, oops, that's supposed to be an x. This is our vertex form in h. So we're just here paying attention to this value. Now notice the generic form here is x minus h, but our function that was given says plus 2. So in order to get a positive there, they had to have plugged in a negative. So in this case, h would equal a negative 2. So when you graph your parabola, that vertex would have been at the x is negative 2. So right here, x is negative 2, and that straight line that goes through that would be your axis of symmetry. So, and then this one, remember a times x minus h squared plus k. This one already is in a minus. We don't have to worry about the negative sign. So our h value is 3. So our axis of symmetry equation is x equals 3. So it's going to go through x at positive 3. So 1, 2, 3. So your axis of symmetry would be here. So let's say your parabola would look something like that. Or it could even look something like that, where the middle is at x equals 3. All right, moving on to standard form. This is the way that we studied quadratics in Algebra 1. So this is what you're used to, the ax squared plus bx plus c, and c cannot be 0. So remember, a tells us if it's a reflection, so if it's positive or negative, positive would open up, negative would open down. It could also tell us about a vertical stretch or compression depending on its value. C is the y-intercept, so where the parabola is going to go through the x or the y axis. And then the axis of symmetry, this one is a new one here, so we're going to have to remember this one. To find the axis of symmetry out of standard form, we're going to have to take the b value and divide it by negative 2 times our a value. So a little extra work on that part. So for example 2, we're going to consider this function and determine, for part A, determine whether the graph opens up or down. So we're going to look at the a value that goes in front of x squared, and that would be a positive value there. So that means our graph is going to open upward. find the axis of symmetry. So I'm going to have to take that b value and divide it by negative 2 times a. So b, remember if we write this here, ax squared plus bx plus c. So b would be negative 4 in this case, and a is a 1. There's no number out front, so it has to be a 1. And then simplify. Negative 4 divided by negative 2 is 2, so our axis of symmetry is x equals 2. Find the vertex. So once you found an answer for part B, you simply plug that number back in for all of the x's in that function. So we're going to have 2 squared minus 4 times 2 plus 6. So that's going to be 4 minus 8 plus 6. 4 minus 8 would be negative 4. Negative 4 plus 6 would leave us with 2. So our x was 2 that we plugged in from part B, and our answer that we got out was 2. So our vertex is at the ordered pair 2, 2. And then D is find the y-intercept, and that is the c value. The c value here in this equation is 6. And then for part E, we have to use that information to graph this. So we know the axis of symmetry is at 2, x equals 2, so that would be this line right here. And we know the vertex is at 2, 2, so the vertex is going to be here. We know that it opens up, and we also know that the y-intercept is at positive 6. So we can kind of visualize that half of the u of the parabola right now. And since this dot here at 6 is 2 away from our axis of symmetry, we can put the other side 2 away from that axis of symmetry because it has to be even. So then we can round out the rest of our u shape, and we have our parabola. All right, for this one, we're going to look at a different function and do the same thing. Determine if it opens up or down. So remember, we have ax squared plus bx plus c. A is negative in here this time, so this one is going to open downward. The axis of symmetry, we're going to have to do b over negative 2a. B in this case is negative 12, and a is negative 4. So simplify that. Negative 2 times negative 4 would be 8. Negative 12 over 8, that is going to be 1 and 4/8, and it would be negative. So negative 1 and 1/2. Then we have to find the vertex, so we're going to have to plug that in. I'm going to change it to a decimal just so it's easier to write. So negative 4 times negative 1.5 squared minus 12 times negative 1.5 minus 3. So remember, you have to square that negative 1.5 first, then times it by negative 4 here. That is going to give us an answer of negative 9. Negative 12 times negative 1.5 is going to be a positive 18. And then we have that minus 3 there. So the two negative numbers together would make negative 12, and we have a positive 18, so that would leave us with 6. So my vertex would be negative 1.56. The y-intercept, remember, is the c value, so in this case it would be a negative 3. So let's put the axis of symmetry on here. It's at negative 1.5, so it's going to be here. The vertex is at negative 1.5, 6. And the y-intercept is all the way down here at negative 3. So it's 1.5 away, so we have to go 1.5 away on the other side. And then we can draw in our U-shaped there. So there's the graph for that one. Now we have to talk about the domain and range. The domain of any quadratic function is always all real numbers, so that's not going to change here. We can use any x value in a quadratic function. The range depends on where the vertex is and how the parabola opens. So the range is the y values, and that vertex is going to be the starting or stopping point. So example 3 says we have to find the minimum or the maximum value for this and then state the domain and range. So if we look at the a value, which is that 2 right there, it's positive, which means our parabola is going to open upwards. That means we're going to have our vertex is going to be the lowest point, so it's going to have a minimum. And then we have to find the x value of our vertex, so we have to do the b over negative 2a. B in this case is negative 2, and A is positive 2. So when I simplify this, I'm going to have negative 2 over negative 4, which reduces to 1/2, positive 1/2. And then find the y value for this vertex. We are going to plug in 1/2. So I'm going to put 0.5 here. Squared minus 2 times 0.5 plus 5. 5 squared is 0.25, and then 0.25 times 2 is going to give us 0.5. Negative 2 times 1/2 would be negative 1, and then we have this plus 5 here. So 5 and a negative 1 make 4, and a positive half make 4.5. So my vertex is at 1/2 and then 4.5. So what that means is that our y value is, if you're thinking about the y-axis, our y value of this point is 4.5. So that means all of the points on that graph are higher than 4.5. So when we write our domain, we're going to write all real numbers. Oops. And then our range, we are going to write y is greater than or equal to, because there is a point there, to that 4.5. Now, if the parabola opened downward, and that would be our maximum point, all the points would be under that, we would just flip that inequality around and say y is less than 4.5. So, but because the dots, the parabola, all the points are above it, we have to say it's greater.